I've had quite a few questions coming up over the last couple of days, asking exactly what happens to the jet unit. Once it's done with its job of lowering Perseverance down onto the surface of Mars. So, in this video, we're going to find out exactly where it goes. For those of you who haven't been following the mission, which is most of you because I only started posting about it yesterday, we launched our latest Mars mission back in July. And that mission consisted of an orbiter, which by now has successfully entered Mars orbit, and a lander that was carrying two very cool robots, Perseverance and Ingenuity. The lander performed a very impressive sky crane maneuver to put Perseverance down the surface of Mars. We watched live as the lander approached the surface, firing its engines to slow its descent and then extending a ramp. Then we saw the jetpack, also known as the Terminal Descent Stage or the MDS, separate from the lander, and fire its engines, blasting red dust into the air as it descended slowly toward the surface. And there have been some suggestions that perhaps the jetpack might have landed with the rover, but it hasn't. There are two parts to this story. First of all, the jetpack didn't land with the rover. Instead, the jetpack fired up again as soon as it was clear that Perseverance had a successful landing and it began to move away from the rover. And the reason for this is so that the rover doesn't land in a cloud of dust kicked up by the jetpack. You want the rover to land on clean ground so that it can use its scientific instruments to study the geology of the area around it without having its instruments clogged up with Martian dust. The second part of the story is, of course, where did it go? It went up. As soon as the jetpack had moved away from the rover, it fired up its engines and shot straight up into the thin Martian sky. And the reason for this is to make sure that if any of the debris from the jetpack falls to the surface, it falls away from the rover. The thing is, though, Mars has next to no atmosphere compared to Earth, and in space, there's no gravity to speak of. So how does something fall? And the answer to that is it doesn't. Any object that isn't tethered to something will just drift away into space. So that's what the jetpack is doing. It's drifting away from the rover, and eventually it will drift out of sight. However, don't worry too much about the jetpack being left behind in space because although Mars has a very thin atmosphere, it still has enough atmosphere for a jetpack to perform a return to Earth. That's right. This thing is going to fly itself back to Earth. But how does it do that? Well, before we continue with the story of the jetpack, let me tell you a little bit about how it works. The jetpack consists of a reaction control system made up of 4 rocket engines that are used to control the movement of the jetpack during descent. These 4 engines are arranged in pairs of 2, and each pair is gimbaled, meaning they can move up and down independently of each other. And this means the jetpack can basically fly itself. On top of these 4 engines sits a vacuum chamber that houses a 5th engine. This is a more powerful engine than the 4 smaller ones, and it uses supercooled liquid nitrogen to expel gas at high speed to provide thrust. It was this engine that was responsible for the plume of dust that we saw during descent. Now, as the jetpack drifted away from Perseverance, it fired up this main engine in reverse to turn around and face the rover. Then, as I mentioned, it fired up the main engine to go up, which slowed it down until it came to a stop relative to the surface of Mars. At this point, it's not in orbit around Mars, but it is in a stable position above the surface. Now, of course, the force of gravity is very weak in space compared to what we experience here on Earth, but it's not zero. So even in space, things will eventually come to a stop if you stop expelling mass to the rear. Now, as you may have noticed, space is a vacuum, so there's no air for the jetpack to breathe. So, in order for the jetpack to move around in space, it needs to carry its own oxidizer for its engines. The oxidizer that the jetpack uses is liquid nitrogen. Nitrogen is normally found as a gas on Earth, but when it's cooled down to around negative 196 degrees Celsius, it becomes a liquid. The advantage of using nitrogen is that it's cheap and easy to come by. But the disadvantage is that it doesn't contain any oxygen. And remember, oxygen is essential for combustion. So how do you make nitrogen burn? Well, you actually don't. You need a catalyst, which in this case is a special gauze material called a Sabatier catalyst. The way it works is that the liquid nitrogen is pumped through the Sabatier catalyst, which makes the nitrogen react with carbon dioxide in the Martian atmosphere. This produces methane and oxygen. The oxygen is then burnt with hydrogen that the jetpack carries on board in its fuel tanks. And the products of that combustion are water and carbon. The carbon is expelled from the jetpack through a special vent, and the water is stored on board until it is needed to replenish the supply of hydrogen in the fuel cells. This means that the jetpack consumes carbon dioxide and releases oxygen. And this is why we chose Mars as the destination for our jetpack. Now, as I said, the jetpack is in a stable position above the surface of Mars, but that doesn't mean it's stationary. In fact, Mars rotates on its axis once every 24.6 hours, so the jetpack is rotating with the planet. What we need to do now is get it into an orbit around the planet so that we can control where it goes. To do this, the jetpack performs a return to flight. This is where it fires up its engines to its speed so that it falls around the planet. Of course, it's not really falling because there's nothing beneath it on Mars. But it's going to appear to fall because it's going to be rotating with the planet. To return to flight, the jetpack performs a series of maneuvers called burns. Each burn consists of firing one or more of the jetpack engines to increase the speed of the jetpack. For the return to flight maneuver, the jetpack will fire up its main engine and maybe some of the smaller engines as well. After a burn, the jetpack will drift away from the planet until it's time to fire up the engines again for another burn. And this process is repeated several times until the jetpack is in orbit around the planet. In total, the return to flight takes around 5 days, during which time the jetpack performs 6 burns. The final burn puts the jetpack into a highly elliptical orbit that extends as far out as Pluto and then wraps around the planet, returning to the starting point. This is important because it means that the jetpack will return to the same place in the sky above the surface of Mars every 26 days. This is the same orbital period as the Mars Reconnaissance Orbiter, which is currently orbiting Mars. Once the jetpack is in orbit, the plan is for the engineers to gradually raise the periapsis, which is the point of closest approach to Mars, eventually. The jetpack will reach an altitude of 500 kilometers above the surface of Mars, where it will remain indefinitely. And this is the end of the mission for the jetpack. Now, I know what you're thinking. Why not send a probe out chasing the jetpack and bring it back to Earth? Well, the problem with that is the jetpack doesn't have any sort of propulsion system to help it along. It's literally just drifting around Mars, so it would take years for the probe to catch up with it. Not to mention the fact that we already have the Mars Reconnaissance Orbiter in that orbit, and it's not going anywhere anytime soon. This has been a presentation of the latest Mars mission. And if you want to see more videos like this, please subscribe so that you don't miss them as they come out. Thank you very much for watching, and I'll see you in the next video.